All right, so we are going to solve the next question. The next question says, a 20 kg mass is to be pulled up a slope inclined at 30 degrees to the horizontal. If the efficiency of the plane is 75%, the force required to pull the load up the plane is... Now, this is a very simple question. If you have something like this, now you are told that the mass is 20 kg. Now this 20 kg will exert a load acting in this direction. Now if you look at it very well, this direction, because the center of mass is somewhere around here, this direction is neither the horizontal axis nor the vertical axis. So we have to find the vertical component. So this one here is going to be our mg. However, this is not horizontal component, neither is it vertical component. So we have to find the horizontal component, which we act this way, and then, of course, the vertical component of this force, which is going to act downward like this. Is that okay? So this is what this is going to give to us. Now, the horizontal component, we said it will be what? Mg sine theta. While the vertical component will be what? Mg cos theta. Now, from what we have learned so far, the force that will be needed to push this body up, F, is mg sine theta. Is that okay? The force that will be required to push this body up is mg what? Sine theta. That is what you are asked to find. However, efficiency was given to you. The efficiency is not 100%. The efficiency was given as 75%. So you have to convert this to in fractions, which should be 75 divided by 100. This will give us 0.75. Now to get the real force that will be required to push this body upward, it will be F will be mg sine theta divided by the efficiency, which is 0.75. Now, if you punch this in your calculator, N is 20 gram times 20 kilogram times G is 10, they will have sine 30 divided by 0.75. Is that okay? So you are going to now press this in your calculator. Any answer it gives to you will be the answer, which is 20 times 10 sine 30 divided by 0.75, which will give us F to be 133.33 Newton. So that is our force, 133.33 Newton. Is that okay? So if we come back here, that will be the answer to that question. Option B. No? Option A. So you should be very, very careful. 133.3 Newton. Is that okay? That is the answer to that question. Let us see the next question. The next question says, a 4 kg ball moving at 8 meters per second. So we are going to write our M1, it's a 4 kg ball, so 4 kg. Moving at V1 is 8 meters per second. Collide with a stationary ball, M2, of mass 12 kg, and they stick together. Calculate the final velocity. Now you agree with me that the velocity V2, because they told you it was stationary. They told you that V2 is stationary. The velocity of V2 of a stationary ball will be what? 0. Now, from the laws of conservation of momentum, it states that the total momentum before collision is equals to the total momentum after collision. But they told you that the both of them stuck together, so they stick together. So M1 plus M2 will have just one velocity. So of course this will give us M1 is 4 times V1 is 8 plus M2 is 12, V2 is 0, is equals to 4 plus 12 bracket V, which you are looking for. Here will give us 4 times 8 will give us 32. 12 times 0 will give us 0. So 32 will be equals to 4 plus this will give us 16V. So divide both sides by 16. This cancel this. Your V will be 32 over 16. 32 over 16 will give us how many? 2 meters per second. So the correct answer to this question is option A, which is equals to 2 meters per second. It's a very simple question, right? Exactly. It's a very simple one. Now let's see the next question. A car travels in a straight line with an average velocity of 80 km per hour for 2 hours, and then an average velocity of 40 km per hour for 4 hours. What is the total displacement for the 6-hour trip? Now, average velocity of 80 km per hour for the first 2 hours. So, what is the formula for distance? Distance is velocity times time. So for the first 2 hours, the total distance traveled will be 80 times 2, which will give us 160 kilometers. Now for the other 4 hours, the total distance traveled will be 40 times 4, which will give us another 160 kilometers. So that the total distance that is traveled by this body will be 160 plus 160, which will give us 320 kilometers. So the correct answer is 320 kilometers. Now the next question says, the work done when a perpendicular force is applied to a body in horizontal motion. Now perpendicular force, it means, what is the formula for work done? Work is F times distance cos theta. Now, if a perpendicular force is applied to a body in horizontal motion, it means that the angle between them is 90 degrees. So therefore, W will be F times D cos 90. And cos 90 will give us 0. So everything here will be F times D times 0, and the work done in that case would be 0. So the correct answer to this question is option B, which is 0. Now, a man pushes at a constant speed a 50 kg refrigerator a distance of 14 meters across a level floor whose coefficient of friction is 0.4. How much work does he do? Now, what is the formula for work? Said work is force times distance. Is that okay? Now, for this particular particular one, the speed was given. A man pushes at a constant speed. Okay, the speed was not given, but the mass was given to be 50 kg. The distance was given to be 14 meters. The coefficient of friction was given to be 0.4. How much work does he do? Now, how do you know the amount of work the person has done? It's very easy. What is the formula for coefficient of friction? We said coefficient of friction, U, is equals to frictional force all over normal reaction. Is that okay? Now, what do you think frictional force is now? To be U times normal reaction. So frictional force will be coefficient of friction. Normal reaction is mass times gravity, which is mg. Is that okay? Because in this particular case, it is actually the frictional force times distance. Is that okay? Now, at the end of the day, frictional force would be equals to, now umg would be equals to what? You think you are going to have coefficient of friction is 0.4, m is what? 50, g is what? 10. So when you do this in your calculator, it's going to give us 0.4 times 50 times 10, which gave us 200 Newton. So that is the frictional force. Now our work done will be equals to 200 times the distance is 14 meter. So W, 200 times 14 will give us 2,800. 2,800 joule. Now, however, if you use 9.8 in place of this 10, that will now give us 0.4 times 50 times 9.8, which will give us 196. So it will now be 196 times 14, which will give us 2744. 2744, which is approximately this answer you see here. Is that okay? So that is that for that question. Let's see the next one. The next one says, which of the following is dimensionless? Now, relative density is dimensionless because relative density is the density of substance all over density of equal volume of water. So that at the end of the day, both of them are density, going to give us 1. So relative density is dimensionless. That is the answer to that question. Let us see the next one. An object of mass 50,000 grams is placed on an inclined plane at 30 degrees to the horizontal. The height of the plane is 2.5 meters and its length is 5 meters. What work is done in moving the object down the plane? Now, we told you that the length is 5 meters. That means the distance that the object must cover is 5 meters. The mass is 50,000 grams. 50,000 grams is written as 50 kg. Now they are asking you, what is the work done? What is the formula for work? Work is force times distance. All right. Now, but they did not actually give you the angle. Okay, they gave you, say it's at 30 degrees to the horizontal. So theta, 30 degrees. Now, my dear student, how do you solve a question like this? You need to look for the force that will be required to pull it down the plane. Now, that force, according to what we said, if you have something like this, we've drawn something like this initially. Let us assume this as the inclined plane, and then we have something like this as the object placed on the inclined plane, right? Now, I told you that there are forces acting. One is the weight acting downward, and then there's another weight that we tend to want to drag this thing up or drag it down. They are equal and opposite. And then there's another weight or that force that acts downward this way. We say this one is mg cos theta, while this one here is mg sin theta. This one is also the one that will be required to drag it down or to move it down. Is that okay? Now that you've gotten this, it means the force for this particular question, the force required is mg sin theta, which should be 50 times 10 sin 30, which should be 500. Sin 30 is what? 0.5. You should know this basic science. 0.5. So 500 times 0.5 will give us 250. So this will give us 250 Newton as the force that required. Now the distance traveled is 5 meters. The distance of the inclined plane is 5 meters. So our work done, which is force times distance, would be equals to 250 times 5. So 250 times 5 will give us 1250. 1250 joule. And that is option C. A very simple question, right? So you must know for inclined plane that the mass will have both the horizontal component and the vertical component. The horizontal component is mg sine theta and the vertical component is the mg cos theta. The force that is required to move the object down the plane is mg sine theta, which will be 50 times 10 sine. Your angle here is 30, which is your theta. And when we did this, it gave us 250 Newton. The distance that will be traveled is 5. So 250 times 5 will give us 1250 joules. All right, let's see the next question. The next question says, an innocent saloon car accelerates from rest to 94 km per hour in 2.2 seconds. What is the average acceleration? The velocity was given as 96 km per hour. We must convert this to meter per second. So it becomes 96 times 1000 divided by 60 times 60, right? That is how to convert from kilometer per hour to meter per second, which will be 96 times 1000 divided by 60 times 60, which gives us 26.67 meter per second. Now the question is, what is the average acceleration? What is the formula relating velocity and acceleration? Acceleration, change in velocity over time. They told you that it accelerated from rest. It means Vf minus V initial all over what change in time. The time given is 2.2 seconds. Now it accelerated from rest. Initial velocity is 0. So you are going to have 26.67 minus 0 divided by 2.2, which will be 26.67 divided by 2.2. So press your calculator. 26.67 divided by 2.2 will give us 12.12. So we have 12.12 meter per second square, which is option A, 12.12 or 12.1 meter per second square. Now the next one, the position of an object moving along an x-axis is given by this. Here x is a meter and t is a second. What is the position of the object at t is equals to 4 seconds? Now they gave you the position as for 3t plus 4t squared plus t to the power of 3. Now at t is equals to 4 seconds, they want you to know the position. Now in that case, what you just do is to substitute the 4 into this equation. So x will be 3 bracket 4 plus 4 bracket 4 square plus 4 to the power of 3. 3 times 4 will give us how many? 12. Plus 4 bracket 4 square is how many? 16. Plus 4 raised to the power of this is 64. 4 times 16 will give us 64 plus 64 plus 12. So we have 12 plus 64 plus 64. That will give us, are you sure? One of these values here is supposed to be negative, not positive. Sorry about that. So if this one here is the negative value, here is negative, here is negative, here is negative. It's going to be minus 64 plus 64. Here we give us 12 plus 0, because minus 64 plus 64 will give us 0, which will give us 12 meters. So the correct answer to this question is 12 meters. Is that okay? Now, this was the answer for the position. If they say you should find the velocity, you have to differentiate the displacement with respect to time. They say find the acceleration, you have to differentiate the velocity with respect to time, and then the opposite of it will be integration. All right, so that is that. What is the correct dimension for viscosity? What is the correct dimension for viscosity? What is the formula for viscosity? We said viscosity is force over area times velocity gradient. Where velocity gradient is velocity over length. What is velocity? LT minus 1 over length. So L cancel L, you have T minus 1. So our velocity gradient is T minus 1. Now, what is the dimension for force? We said force is NLT minus 2. What is the dimension for area? Area is L squared. So that at the end of the day, this will give us MLT minus 2 divided by M squared times what? T minus 1. Now, M squared will cancel one of these M here. This all comes up. It becomes M minus 1. Touch you something like this. Then this L here will still remain. Are you sure? I'm not making any mistake. So it's still going to be L. And then this T minus 1 crosses up. It becomes T minus 2 plus 1, which will give us M minus 1 L, then T minus 1. That will be the answer to that. Oh, sorry. Now I see where the error is coming from. Sorry about that. This M. The dimension for area is L squared. So it's supposed to be this L cancelling this one here. And then you are going to have our M. L crosses off, becomes L minus 1. T minus 2 plus 1 will give us minus 1. Is that okay? And that makes option B the correct answer to that question. So when you see this question, the correct answer is option B. And I think that is the end to all these question answer series. All right, we'll see you in the next one. Bye-bye.